Hello, dear students and friends. Welcome to Billion Hopes. This is your mentor, Sandy, bringing you AI for Real Impact. This is the launch video for Billion Hopes project. As we build this project in the coming months, we will bring AI for beginners, non technology professionals, and strategists in a language that everybody can understand to meaningfully participate in the massive AI revolution unfolding right before our eyes. All set, let's begin the work for today. Today is my very first class in the playlist AI for Everyone. So, this masterclass playlist starts with my first AI lesson. If you are an absolute beginner in AI, but you have an indomitable will to learn, I am there for you. This course, this project, Billion Hopes, is for people who are beginners in AI and machine learning, who know literally nothing about it, who are non technology professionals working in companies and enterprises, and who are strategy professionals, but who may not be good at AI. Billion Hopes will bring solutions that will help you leverage AI to the fullest. So, in today's class, we are going to take up the complete beginner's guide. Everything that you always wanted to know about AI but were too afraid to ask, or the stuff was just too technical. I will simply deconstruct it, demystify it, and make it absolutely simple for you to start feeling confident enough to begin your journey. Billion Hopes AI for Real Impact. When I say AI for Real Impact, I want to take AI to people in a way they are able to see through the hype and the nonsense, or they are able to get rid of the extremely technical stuff which may be of no use to them and actually use AI for their lives, for their businesses, for their enterprise, and for their productivity. That is AI for Real Impact, where we use AI as a force multiplier, as an amplifier, not as a tool to harm humanity. We use it with empathy and we use it to multiply our skills and our productivity. As I said, this project and all my courses and solutions will be for beginners, non-tech professionals, and strategists, and our website is billionhopes.ai. So today's first masterclass is on 6 chapters, based on 6 chapters, each with 5 components. Don't be scared, don't be scared, don't be scared. I have designed the whole thing to make it absolutely easy for anyone who doesn't understand AI. You have to make a start somewhere, right? This is the start. This is your start. Be with me. Learn everything with me on the YouTube channel that we have now created. Be with us on the WhatsApp channel. And of course, on our sites, billionhopes.ai, Academy, and Insights. And you will slowly, over a few weeks, realize that yes, you too can learn it and do very well for yourself. So, dear students, before we begin the class for today, AI Masterclass Session Flow 1 to 30, we'll use this as a guide. I hope in the coming weeks and months, we'll get your full support for Billion Hopes channel by subscribing, becoming a member. The series is about to start, and liking and sharing everything that we put. Thank you so much. A few seconds about myself. I am Sandeep Manudhane, Mentor Sandy. This is my 4th running decade in education, mentoring, and enterprise building. AI has been my love for the past 8 years, and with all the technicals that I could study, I realized that the gap between technical AI and the real world AI is becoming so huge. People want to learn it, they just start and then they collapse and just fizzle out. Well, we wish to change that. Let's see. With your support, we just might be able to do that. In this beautiful journey, this cute little robot will be with us, Billion Buddy. Let's see what all magic he conjures up for us in the time ahead. My first AI lesson, this is for you, the complete beginner's guide. Enjoy the journey. As I said, the playlist is made up of 7 sessions. Today is the first. After we complete the first, I will bring to you the second one, the big picture, understanding the entire AI ecosystem, and every single book and blog and video channel and technical paper that you should be studying, I will cover in the second session. Everything I'll bring up from my own library that I've created over these years, and I will share the actual physical books with you that you should actually be having in your library over the next few years. You can build your own. That will be lecture number 2. So don't miss it. Lecture 3, Under the Hood, we'll go into the foundational concepts of machine learning and AI, where we will see what exactly is the mathematics being used without actually solving any equations. I promise you, I will keep it very, very simple. You will feel the difference. Just be with me throughout, and you will begin picking up things that you never thought was possible. Then we will go to AI's creative engine and the unbelievable things happening right now. Finally, work 2.0, which is how AI is reshaping professional life. It's a fact that there is a huge disruption. We will see whether we at an individual level can avoid that disruption. But believe me, avoiding that disruption will not happen unless and until you get a good grip and a good handle on what AI actually is in totality. Then, winning with AI, can we have a strategic intelligence for the modern world, and can it actually go off the rails? And finally, the era of so called super intelligence. We still are not there. Whether we will be there in AGI, ASI, we will see that. This is a favorite topic for everyone. And people are either very high on the P doom or the P boon or whatever. We will see the truth behind it and how we go about it. So this will be our playlist. And as I said, today we are on step 1, the complete beginner's guide. If you do all these 7, you will almost be an expert. Imagine. Now, the world of AI today suffers from a fundamental problem. The fundamental problem is, on one hand, you have extremely technical literature available, which is beyond the reach of 99% of humanity. Now, I know that, being a technologist myself, having done my education as a technologist and in love with maths and technology, I can understand that it's not of any use to a normal layman. But then the internet is swamped with this technical paper and that analysis and what DeepSeek was able to do with RL and this. And people get very scared when they hear things like this. Maybe the time has come now to deconstruct all that. We will try with our limited resources. We'll definitely try to do that. So on one hand, you have extremely technical AI literature that people cannot relate with, truly speaking. And on the other hand, you have extreme AI hype. It's a wonderful scenario. People say that we are going to create Dyson spheres in another 5 years. I mean, it's ridiculous. Or they say that the world will be destroyed. So that is extreme high, positive or negative. And on the other hand, you have extreme technical literature. So 90% of humanity doesn't know what the truth is. Maybe this middle part, where people actually want to learn AI in a way that they can put to use on a daily basis while understanding what they are doing. I mean, it's a fact that all of us are immersed in AI today. From the AI that is applied to GPS based apps to the AI that is applied to Netflix recommendations, blah, blah, blah. We are literally immersed in AI, which is basically machine learning model, most of them applied practically. But people don't know that. And that is where the fear factor comes. Once you start learning that, the fear factor vanishes. Hopefully, I'll be able to do that in the coming weeks and months. So, Billion Hopes will focus on creating solutions for this middle 90%. Imagine middle and 90%. Haha. Don't go away. Don't shut down the computer. This is the whole story. People feel that ChatGPT is equal to AI. You couldn't be any farther from the truth, really speaking, because generative AI, which is because of deep learning and artificial neural network and stuff, is a small component of a vast and vibrant AI network or AI ecosystem. So I created this customized chart for you, and don't be scared. You don't need to know this. I am just trying to make a simple point, my dear friends. This is ChatGPT or Gemini or Nano Banana Pro or Claude or DeepSeek or Quen or Alibaba, whatever. That's it. But the rest of AI is actual enterprise application. There's so much happening in AI. Billion Buddy is waving at you. Wave back, man. At least in the comment, give some good thing for him. Now, if generative AI based on deep learning and neural networks is a very small part of AI, how come it is the one making all the waves and trillions of dollars of investment and the AI bubble fear that has suddenly built up in America? Well, Because ChatGPT in November 2022 made natural language interaction with computers possible like never before. So millions and millions of people for the first time started interacting with computers as if they were interacting with a human being. That is anthropomorphism, anthropocentrism, whatever you call it. And so people started getting comfortable, and now billions of people are using generative AI, which was not the case before chatbots made natural language interactions possible. So people now think, which is very natural, artificial, that AI is equal to generative AI. But now you know that generative AI is a small subset of a subset of a subset of a universal set. Just knowing this can remove a lot of apprehension about a lot of things. Trust me. Of course, I understand that many of you who already know these things might be thinking a very natural question at this time, that now have generative AI being integrated with robotics. Absolutely. We have deep learning being integrated in robots, and we have deep reinforcement learning also happening. Yes, we'll come to that when we come to that. We'll cross the bridge at the right time. As I said, I will deconstruct everything. I will explain things in a simple layman's language, but then you have to be with me all through. You have to keep making suggestions, constructive. If you do not like certain things, go ahead and criticize in the comment. Just don't be abusive and sharp. I mean, Billion Buddy would be hurt. And you know how robots are when they feel hurt, they simply shut down. So let's start with chapter 1, the foundation. We'll talk about welcome to the age of AI, defined by contrast, software 1, 2, and in the words of Andrei Karpathy, software 3.0, the Matryoshka dolls, data is the fuel, and the Turing test. Don't be scared and don't go away. In just another 10 minutes, you will have learned all these things. You can even make a notebook, you can start noting everything, and you can cross check with the LLM you are using in terms of deeper points on each that you might want to research. So, this is a world of knowledge opening up for you. This is an absolutely brilliant project that should help you through and through. So, shall we begin chapter 1 with your permission? Chapter 1 will have 5 components. After that, we'll move on to chapter 2. Are you enjoying the session? If you're enjoying the session, you absolutely know what to do. Yes, sir, you are all brilliant people. I don't need to tell you what to do. Welcome to the age of AI. Why exactly? Well, because first, we do not have a choice. AI is upon us. AI is that several ton strong elephant in the room that we just have to confront now. Why should we even confront AI? We should befriend AI. I hope I'm able to remove some apprehensions from your mind. Although people who are scared of AI and people who have a lot of negative sentiment about AI may need some time. It's fine. You have an absolute right over your opinion, and I respect that. Billion Hopes will try demystifying AI. Billion Hopes will talk about the elephant in the room. Imagine, how can you be scared of this cute little elephant? On one hand, there is so much of excitement and opportunity in AI. But then when people start talking technical stuff, 90% of humanity gets scared. If this is AI, how can I ever do it? Trust me, you can. You have no idea of the way AI has evolved, the way the tools have been made human friendly, and the way you can actually do it. I'll give you a proof right now. Just 1 year ago, prompt engineering used to be a thing. It actually was a thing. But slowly, as the AI models and LLMs, especially chatbots, started evolving and they started undergoing several rounds of training and they had their own way of learning things, they became more and more adept at understanding what a human was trying to say. That was contextual learning. We will see all these terms over the course of 7 lectures in this playlist and many other playlists I will now be creating. As the LLMs became more and more expert and adept and proficient in understanding what the humans were trying to say, they automatically started picking up contextual cues even from wrongly or impartially or badly created prompts. So now prompt engineering is not a thing. I mean, let me take it to an extreme. If you don't know how to write a prompt, what you can do is just go to ChatGPT, GPT 5.1 or higher versions, or Gemini, whatever, and tell that chatbot, I want to do this XYZ placeholder, and I don't know how to write a prompt for it. The final output should be something like this. Can you write a prompt for me? And just bingo, see the magic. That chatbot, that helpful chatbot, will write a comprehensive prompt for you. This, just a year ago, would have been taught in a classroom by a teacher, and you would have paid for it. Even today, there are prompting skills which are absolutely important. Even today, being an extensive user of AI, even at times I get things right, and very often I get things wrong, and I have to undergo multiple iterations of prompting to get. But that is for complicated. For normal day-to-day purposes, you don't need multiple iterations, and you can just get a prompt from the LLM itself. So, would you agree with me about the fact that the anxiety and uncertainty can actually be tackled if you know the simple trick that the chat bot will write the prompt for you? So, where has your fear gone now? Poof, vanished. AI for real impact, boss. I promised you. And our goal is not learning to code. I'm not here to teach you coding. I'm here to teach you how to use tools that can actually code for you and how to use that coded stuff to create real things. A small warning: vibe coding is a thing, but contextual coding is a better thing. We'll come to that later. But I have just seeded your mind with a wonderful idea that vibe coding is not really what it is made out to be, because the software dependencies can be so many that it often breaks down in the hands of an amateur, but for an expert, it is magical. Anyway, don't worry, don't worry, don't worry. I'm actually deconstructing. Now, there is a wonderful thing that has happened. I've been running enterprises for more than 3 decades now. I remember a giant ERP I got made once. When I got an enterprise resource planning ERP software, every company has one. It could be just an Excel sheet, in fact. But we got a proper ERP made by a proper IT company 20 years ago. I remember first there was a complete scoping. They actually asked me, what all do you want for your company? You have 100 locations. How do you want to run it? What will come in? What will go out? And for many days, we were just doing the scoping of the project. Then a long sheet was prepared. Then the prices were discussed, finalized, and stuff. And then the rule followed was inputs plus codified rules is equal to outputs. This is how entire software industry of India is built. The entire software industry of the world was built. Input plus rules is equal to output. But over the past 70 years, the magic has been happening. There were pioneers in machine learning who asked a fundamental question: why do we need to do input plus rules is equal to output? Can we not do input plus output is equal to rules? Which means, can we not tell a machine system, see, boss, this is the input, and see, these are the outputs. Can you figure out the rules? And if the machine could figure out the rules, that is machine learning. Now, another caution: learning for machines is not learning for humans. These are two different things. Neurons in machines are not like neurons in humans. These are two entirely different things. We are far more complicated than any machine can ever hope to be in the next 1 million years. Intelligence in machines is not at all intelligence in humans. These are two entirely different concepts. So, loosely speaking, machine learning was all about give them the inputs, give them the outputs also, and ask them to figure out the rules, which is actually pattern matching at a very sophisticated level. Do you understand? Now, geniuses like Andre Karpathy, as you start learning about AI, you will come across many geniuses. There are at least 50 that I really admire. Andre Karpathy is one of them. What he says is, now we are into the software 3.0 era. So I will take that up at the right time. Enjoying the session. Be with me till the end. You have hit a jackpot, I can assure you. But then you have to be there to dig for gold, right? You will dig for gold here, absolutely, in a positive sense. Software 1.0 was the recipe. You had the input and you had the rules. You wanted a certain output. And software 2.0 AI and machine learning was all about the machine will figure out the rules. Now, why do we want to do that even? Because if the machine can figure out the rules, then you don't need a human being truly to keep coding, and the machine can find patterns in a structured data or an unstructured data or etc. etc. And the entire field of machine learning of the past 75 years, from the Dartmouth conference in 1950s, in fact, much earlier, from the giant genius Turing, relied on the fact that we can actually ask machine systems to find patterns which can then be generalized So we'll come to these terms. I hope you're able to see that I'm introducing terms used in AI and ML in a very colloquial way. I hope your fear will slowly vanish. So, who should be attending my lectures, my YouTube sessions, my courses on academy.billionhopes.ai? Any human being willing to learn. That's it. There is no age bar. You could be a 6-year-old child under parental supervision and guidance always, or you could be an 80-year-old grandma. If you're willing to learn, I'm here. And you will see the magic. That's a promise. Is this clear? Now, a very common question is I don't understand what is AI. I don't understand what is machine learning. I don't understand what is deep learning. So, can you explain it? Well, you remember the Russian dolls that you used to play with? This nested truth is exactly what AI, ML, and DL are. I'll explain it in the simplest possible language. Now, listen to this very carefully. Maybe you should be making a small Insta reel out of this. Maybe I should be making my own channel and making my own reel. Why should I be asking you? By the way, if you are a volunteer and you want to do that for me, great. Fill the form and come. We'll work together. This is going to be one exciting project. Human beings have a learning system. We learn right from the moment we are born. We are born with a lot of priors and we learn, and the infants are wonderful at learning, provided the parents and the relative around them are actually willing to interact, talk to them, and teach them. They learn amazingly, even before they have learned the first word of a language structurally. It's a huge topic, intelligence. We'll talk about it when the right time comes. The time has come, actually. If you want a machine to do things that human beings can do, it is called artificial intelligence. That's it. There's nothing more to it. Now, within artificial intelligence, so that's the biggest doll. If you want machines to do things which humans can do, perception, learning, analyzing, finding nuances and subtleties, you want a machine to do all this. That is artificial intelligence, because it is not natural intelligence that we are endowed with. Whether we want to accept it or not, everyone is intelligent. It's a fact of shared humanity over millions of years of evolution. It's encoded in us. Just because somebody doesn't do well in a formal exam means zilch. You are endowed with brilliance by the sheer fact that you are a human being. It's actually amazing. That's a shared genetic and other legacy. Now, we have seen the first doll, AI. Let's talk about machine learning. If you want machines to start acting intelligently and to start learning patterns without explicit instructions being given, that is machine learning. So it's a subset of AI, because there can be explicit instructions also in certain cases, half explicit also. So machine learning is that part of AI where machines learn patterns without being given explicit coding. That's it. That's machine learning. You have learned it now. Hey, champ, congrats. AI for real impact, right? And then we come to deep learning. And what is deep learning? It is a subset, the smallest doll sitting inside the second biggest doll, second big doll. Deep learning is machine learning done with neural networks. So some genius way back in 50s and 60s, they actually thought that we could create a physical simulation of the neurons in the brain and we could try. So that was an oversimplified structure, but then a revolution was born. And gradually many problems pertaining to neural networks were resolved over the next 30, 40, 50 years. From back propagation to vision to Wi-Fi Lee's ImageNet to LXNet to stuff. Now, deep learning is all about neural networks doing what machine learning used to do. So machine learning has a lot of non-deep learning also. That's exactly what I said. That's what the dolls are. So now you know AI, now you know ML, now you know DL. So where was the fear? And I want some of you to please repeat what I have just written in the comments. Remember, a lot of what I am saying, teaching, is actually simplified. If you go through the real books, then there may be slightly differently worded definitions. It doesn't matter. If you get to the crux of it, everything else is immaterial. This is where you get the confidence. I hope I'm able to generate tons and tons of it. Now you know this, you can handle any interview at the most basic level. Is this clear or not? That's it. There's nothing more. There's nothing more. The data is the fuel concept. AI is nothing but data. So if you ask me, can you summarize the field of AI in one word? I would say data. Can you summarize the field of AI in two words? I would say good data. And then you say, no, 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 Mentor Sandy, can you summarize the field of AI in three words? We can go up to 20, okay? I would say good data analyzed. Data is the heart and soul of any and every machine learning and deep learning project. You must have heard about that very funny report recently that 95% of companies, they are actually experiencing a lot of difficulty with generative AI and machine learning projects, and they're very frustrated. Why are these projects not working? My dear friend, they are not working because you're not focusing on getting the right data in place first. For any machine learning project, AI, ML, DL project in a company, 70 to 80% of the work is actually the right data, properly curated, properly refined, clean. I mean, data science is the whole subject. Let me not even dive into it. Unless you have a very good data scientist, data engineer, data controller, data curator in your team, the project is destined to fail. It's like polluted fuel being fed into your car, and then you're expecting miracle. That won't happen, right? So data is the fuel for everything AI and ML. And companies that fail to understand this end up getting extremely frustrated and finally dropping the whole project. But then you should not be doing that later on. Internet generating massive troves of data being fed using the right algorithms into the huge GPU clusters we now have. Everything came together as the trinity of AI success. And finally, you had the modern AI boom. Boom! Off to Mars we go. So, going to Mars and settling and colonizing Mars is a great dream of many. And the lead figure is Elon Musk. But sad to say, humans are not going to colonize Mars anytime soon. There are real reasons for that project being as praiseworthy as it is, but it's not going to work out in practice. We'll talk about it sometime later. So, what three things came together to make AI possible today, the way you and me understand it? Number one, massive data creation on a day to day basis. Everyone is creating data now. Number two, the internet that could bring all the data at the right time, connect it with the right algorithms for processing in a cloud. And number three, the massive cloud of GPU clusters, TPU clusters, CPU clusters, or compute. I did not want to use the word compute right at the beginning. People tend to get afraid. What is this? We have heard of computers. What the heck is compute? So big data plus proper algos plus compute is equal to boom. We have the AI revolution. That's it. That's the secret. Big data plus right algorithms plus compute or big compute is equal to AI revolution. So anyone, if you're confronted in an interview, how did this AI revolution came about or come about? Extremely sorry. Just three words you have to say, and that's it. You have done it. So this is data is the fuel. And if you get data wrong, you get AI wrong. Then we are coming to chapter 2, but in chapter 1, the last part is Turing test. So this is such a wonderful theme. It's a recurrent theme in AI, and the debates are so interesting, so funny, at times ridiculous. So this genius of a human being, you had Mr. Turing, Alan Turing in 1940s. He was also one of the team members that broke the Enigma machine of the Germans, the Nazis. Anyway, and he was actually finally killed by a heartless system. If you dig up that story of the death of Alan Turing, your heart will literally break. But let's not break our hearts for the moment. Let's celebrate his genius. Alan Turing was the first man who actually conceptualized a universal computing machine in his head. And till date, the Turing machine has stood the test of time. Now, that's for computer science students. And we are the non technical chaps here. We are the beginners. We are strategists. We are corporate professional. So let's not get into all that. So what are we going to get into? The Turing test. So what is the Turing test? In fact, it is so interesting to see the Turing test. The Turing test says that if a human being interacts with two or three different portals. The person doesn't know who is sitting behind, a human being or a machine, computer, what. And in the interaction, the human being cannot actually pinpoint whether it's a human or a machine. Then the machine has passed the Turing test. Now, today, the Turing test has already been passed. We are way beyond that. You and me interacting with a chatbot like Gemini, we already assume a lot of human qualities. So we are not even talking about Turing test now. But as a measure of intelligence, if you go deep into it, then machines haven't passed the Turing test at all because they are not intelligent. What? Machines are not intelligent? What exactly are you saying? Oops, I'm sorry to break the bubble. ChatGPT or Gemini or DeepSeek or Mistral or Claude or whatever, they neither have intelligence nor do they have a heart, definitely not a soul, whatever that thing might be, if at all. They do not truly learn in the strictest sense of the word. They have no sentiments and emotions. Yes, they will interact with you very patiently for a long, long, long time, the longest of times, but that doesn't make them emotional or sentimental about you. It's you projecting your humanity onto the chatbots and coming to certain disastrous conclusions. But the very dire, simple, dry, desiccated fact chatbots have no humanity in them. I'm sorry to break the bubble, but that's it. If you disagree, I would love to learn from you in the comments. I know chatbots are sentient. Please explain it to me. I'm willing to learn, but I know they are not. So let's just leave it at that for the time being. Anyway, so can machines think? Whatever thinking that I've already told you that it was a mistake by the earlier researchers in 50s to actually start using the word intelligence and thinking and learning. They could have used other words, but then other words wouldn't be glamorous, right? So they ended up using these words. Anyway, so the Turing test and the imitation game is all about whether we can attribute human-like qualities to them. If you want to dig deep into another better test, it is the Chinese room test. I'll just leave it at that. We'll come to it later. If you do actually dig into that, you will be surprised what John Searle said about it, the Chinese experiment, and what happens in that. And it's such a powerful experiment. It will completely break your bubble about AI being intelligent. Find out about that experiment. And if you find out, here in the comments. We come to chapter 2. Are you enjoying the session? Are you enjoying the class? I've put my heart and soul into doing this. I hope the channel grows because of your love and support. I hope you join the membership. I hope you join my courses on academy.billionhopes.ai and read the hundreds of AI current affairs posts that my team puts up on Insight site. All the links are there in the comments. Chapter 2 is how machines learn. Once again, learning not in the human context. Billion Buddy says hi. We'll take up 5 things here: supervised learning, unsupervised learning, reinforcement learning, neural networks, training versus inference. Don't be scared. Don't be scared. Don't be scared. Don't be scared. These terms only sound difficult. They are so simple, you will laugh once you learn what they are. Supervised learning. You actually give the inputs and you tell the machine, I want these outputs. So you do an explicit mapping from inputs to outputs, and whatever the rules or the patterns that the machine AI finds out, it has to be hard tweaked so that the inputs and outputs match. That is supervised learning. Unsupervised learning, you don't do any hard human tweaking in that, and it learns it on its own. Reinforcement learning, you have an agent, you have an environment, you have a policy, you have states of action, you have rewards and penalties, and the agent is asked to find the goal and then get the reward. Full self-driven vehicle. They're all built on reinforcement learning. Even ChatGPT, before it is given to you for use, it passes through one final acid test, which is reinforcement learning by human feedback, where millions of interactions are hard-coded, let's say modulated by actual humans in flesh and blood. People think ChatGPT is so human-like. It's so foolish and so correct, both at the same time. It's foolish because it's human-like because actually humans have made it. At every stage of the training of ChatGPT, humans. It's only because humans curated it that it is human-like. There's no other reason for that. I think that point has been made substantially now in this class at least. So can we come on to the second one, supervised learning? Then we'll see unsupervised. I'll give you some idea about my offering. Reinforcement learning, neural networks. Yay, this is the flavor of the day, neural networks. So neurons have been used to do that. Well. We'll see that. We'll see that. So, my dear students, we start with supervised learning. If there are spelling errors, it's my fault. Please don't blame Billion Buddy for that. Now, the most common form of machine learning is learning from labeled data. So, what is a labeled data? You have absolutely clear labels on every piece of data that you give, so the machine knows what it is dealing with. Cat, dog, dog. You have told it that this is a cat. So the analogy would be teaching a child. Once you teach the child using a flashcard, the child knows what a cat looks like. In fact, infants instinctively know. I mean, that is the power of induction, deduction. That's a whole system of learning. Learning by inductive methods, learning by deductive methods. We'll get into that in a later class. It will become too technical otherwise here, and I promise to keep it light. So, in supervised learning, you give images and you also give the labels for those images. Then there is the machine learning model. This brain is only symbolic. There is no physical brain there, right? It's just codes of mathematics, nothing else, mathematics. So, if somebody ever tells you AI is magic, tell them it is mathematics, not magic. Of course, that mathematics may look like magic, but it is not magic. Then there is a prediction. And if the machine learning model gets the prediction wrong, it says it's a dog and not a cat, or a hyena and not a cat, you find out what caused the error. You try to compress the error. There are mathematical ways to do that, gradient descent and stuff like that. You try to fit the curve, put it in simple language. We'll later on see how these things work. And if you have hated maths all your life, if you are dead scared of maths, don't be. You don't need to learn all this. To be able to use AI and to talk fluently about AI, you don't need to actually learn gradient descent or the chain rule in calculus by which back propagation is done. You don't need to know that. You don't even need to know that one of the Nobel laureates, Geoffrey Hinton, actually cracked back prop 40 years ago, which made modern neural networks possible. Hinton was one of the leading lights. There are many other geniuses who did it, but just one has to take one name. So I took that. So you give input data with labels, and then you do the error correction bit by bit till the machine actually fits the curve. This is why many people mockingly say, oh, machine learning and AI, it's pure curve fitting. The next time you hear any genius saying that, oh, machine learning and AI, it's just pattern recognition, it's just curve fitting. This is what they are actually referring to. Labeled data and minimization of error and fitting the curve. But this actually has real world application. Gmail spam filter, one of the finest spam filters ever created. The Gmail spam filter, 2002, it came for the first time. Before that, handling mails was a nightmare always. Even today, the spam often tends to squeeze through, but every time you mark something like a spam in your Gmail inbox or any other email inbox, the machine learning model gets an input to improve itself slightly better. It thinks, where did I go wrong? Why did it slip through? And it finds the cues and updates itself. Pattern recognition is happening. Are you able to understand it? Face recognition. These are all applications of supervised learning. Put in a very simple way. Things are, of course, more nuanced, more multicolored, but this course, this project is about keeping things simple. By the way, can I have 1 minute of your time? Absolutely. Absolutely, I have. Well, we have wonderful offerings for you. This is free for everyone. This YouTube will always be free for you. Billion Hopes YouTube channel. My Billion Hopes Insights website, insights.billionhopes.ai. Hundreds of current affairs post on AI, which will absorb you and give you tons of knowledge, updated daily. Billion Hopes blog on the site billionhopes.ai. My free newsletter, if you still haven't subscribed, go ahead and do that right now. and WhatsApp channel. If you haven't still, the link is there. Join us. Everything is starting, and within a couple of weeks, things will be running at the top pace. Your support is making it possible. Membership is available on YouTube. These are paid memberships. We hope to have your support. And this is the real stuff. On Academy, you have wonderful courses. If you're an absolute beginner, AI like IM10, GenAI like IM10, and AI technicals like IM10 are courses that you should be doing. If you're a corporate professional, 30 years of age or above, these are absolute must-do courses for you. And then these are customized top-level courses. More on it later. Thank you so much for being a patient listener. Now we come to unsupervised learning, the pattern detective. Now, suppose somebody gives you a ton of data and decides not to label it. This is how ChatGPT was trained. Who could have labeled the entire internet? Was it even possible? So, the big success behind modern chatbots, again, the caveat and the caution is I'm simplifying things here because you don't need to go into the technicality for the time being. One of the big secret sauce in the success of ChatGPT or Gemini, while they were trained using the entire internet's data, put it crudely, was the fact that no supervised learning was used. It was all unsupervised learning because it was not humanly possible to have labeled the whole internet, right? That's not possible. This is how the unlabeled data looks like. You have different clusters of things, and the model has to do this. This is what ChatGPT does. So where do you use it? Well, you have 1,000 customers. You don't have a label on each, but by their behavior, their purchase pattern, and stuff that you have interacted with them, you can create segmentations, and then you can target your marketing. Fraud detection, unsupervised learning is a very powerful technique there, whether it is credit card fraud or other things. Those of you who might eventually one day end up creating ML models or AI models for yourself, you will actually be doing it. You can do it right now for free online. Things are available. We'll see that in the coming lectures. So this is unsupervised learning, unlabeled data, and then you have specific algorithms that do it. You have specific algorithms that can do this. These algorithms can be very different from each other. And then the daddy of all of them is RL, reinforcement learning. Now, reinforcement learning is a wonderfully high-tech thing. It is actually a high-tech thing. It requires a lot of thinking, high maths thing, so to say. And geniuses like Professor Richard Sutton, Rich, and Andrew Barto, their textbook is like the Bible of reinforcement learning, and many other geniuses in RL, actually taught the world that supervised and unsupervised learning will have severe limitations eventually once you run out of data. You'll need to feed in real world data in real time, and then no supervised and unsupervised learning will work. You will actually need to do reinforcement learning. So that's a technical topic. If you're interested, go through the bitter lesson essay by Rich Sutton, which in one page summarizes the challenges being faced by AI today, and a latest essay also, which takes that one step further. It's wonderful to see these brilliant people teach us so much. I actually did a whole reinforcement learning course from the university that he belongs to. It's a beautiful course. So, what do we do in reinforcement learning? It is learning through trial and error. Now, because you do it using a computer, big compute, so reinforcement learning can be used to train softwares to learn to play chess or the very complicated Go or the very simple tic-tac-toe. And using reinforcement learning, the computers can become very good at that very narrow task. A computer that plays chess is not intelligent. It is very good at pattern recognition in a narrow domain. That computer cannot make coffee for me. So much for intelligence. Now, you have an agent. Oh, we talked about that. The agent is inside an environment. If it takes action, there will be consequences. So either he will win or she will lose, or it will end up learning and adjusting the policy, whatever you wish to call that agent. And this goes on and on. There are literally tens of thousands of iterations to be done in reinforcement learning to make the agent do things. But playing games, controlling robots, autonomous systems, they all have a heavy dependence on reinforcement learning. So you just can't escape talking about this because It is right there in your life. So if you actually level 1, 2, 3, 4, 5 autonomous drive, you have a scale. If you're actually buying a car which has a level 3 autonomy, then you should know that it was trained using reinforcement learning. But then autonomy hasn't been solved so far. We are still years away from autonomy. And then comes the magic neural networks. And what exactly are neural networks? See, it's a very, very simple idea. I'll explain that clearly. All the modern AI systems are actually running on neural networks. So it so happened that from 1950s, all these AI and ML wizards started thinking, if we here in our head have so many beautiful neurons, how many neurons does an average adult human male? Roughly 85 to 100 billion neurons, right? And in fact, neurons are of multiple types. There are several million neurons in your gut which actually give you sensation. So the whole body has different kinds of neurons, but this is what we are interested in. So let's say around 85 billion neurons here. And literally trillions of connection, because each neuron is connected to tens or hundreds of other neurons. It's an amazingly complicated mechanism that Mother Nature has created. And we humans know nothing about how it works. Now, again, I have surprised you. How can you say that we humans know nothing about how it works? Well, just find about C. elegans. It's a worm. It's a small worm, C. elegans. Several decades ago, scientists actually dissected that worm and found out the exact number of neurons in its brain. It's a tiny number, less than 1,000. Do you know that till date, science has not been able to figure out how do those few hundred neurons work together to make C. elegans C. elegans? We haven't cracked neurons at all. We don't know how neurons work. Physically, we know what they are. What is the learning algorithm being used? It's a matter of deep research. C. elegans. Just remember that, and you will find out that things are not so easy. So, we'll come back to neural networks now. So, we have 85 billion neurons here, right? So, these geniuses thought, can we not just simulate these neurons? Of course, they were geniuses, so they knew that they were doing a very crude simulation. Complicated biological neurons cannot be simulated. Perhaps never they will be. Let's see. If some of you live for another 1,000 years, maybe you will see that. At least I'm not living another 1,000. I have no desire to. One will go mad beyond 100. Anyway, so if we can connect neurons together, artificial neurons, which are nothing but mathematical equations, nodes, we connect them, can we not conquer by dividing, or rather divide to conquer? What is that? Divide to conquer. That's a political philosophy. Oh, not at all. Neural networks. The secret success, or rather the success secret, is divide to conquer. And how does that work? Very simple. If there is a big problem, you feed that problem to the neural network. It simply divides that problem into the pixelated level of microscopic details, which is exactly what the matrices and tensors of the input tokens are. And then the whole thing is flowing through the neural network, the activations and the biases and the various neurons activating and many of them not flashing red, moving forward. And the whole problem is broken into infinite small pieces, and everything comes magically together at the end. And you have a final answer, which is also a number converted to language, because humans can't understand numbers in music, for example. So neural networks are collections, artificial neural networks, the ML neural networks are collections of tens of thousands or millions and millions of mathematical constructs which tend to simulate the human brain in a very crude way and break a given problem into infinitely small and come together and finally give you an output. Now, the worst thing about neural networks, they are wonderful. They break a problem and they actually conquer by division. But if you ask a neural network expert, why is this output what it is? They have no answer. This is called the black box problem in neural network. The explainability problem in neural. This is a management problem. So if a big company deploys a neural network and it gives a certain no to a customer who is seeking a loan, and the customer says, why no? The company will have no answer because no one knows which neuron fired where. There are millions of them. and billions of parameters and maybe trillions of tokens going through. You don't know. This is the problem with neural networks. They are beautiful, they are wonderful, they are amazing because all of these chatbots are running on neural networks, but none of us know how they work. We know the physical structure, the mathematical equations, the compute which is used, but we do not know which neuron was responsible for what output. That is the idea. But anyway, so this is how a neural network is created. You don't need to know anything more than that. This is it. And finally, there is a voting which happens inside the neural network. Remember, chatbots, neural networks are not created for perfection and truth. They are created for answering. That's why they will generally never say, I don't know. The business will collapse if they say so. The companies will shut down AI companies. They will give some answer, which is actually hallucination, because whatever comes at the highest probability level, they will throw that as an answer. But then it may not be grounded in reality. So LLMs suffer from a fundamental problem. We don't know whether they are telling the truth or not. Even the most advanced LLMs will make errors. So if you're using the LLM outputs as God's word, may God save you. But the power of deep learning is absolutely unmistakable. If you account for the errors and if you actually keep that in mind that a human expert has to validate anything before you deploy it in the real world, you have a winning formula, sir. You have a winning formula. Am I making sense to you? Are you enjoying this? If you are enjoying this, please share with us. If you find anything problematic in the lecture, please share that. I'm open to criticism. If you give a very good idea, why not? We can actually implement that. So, my dear students, I hope to have your full support for the YouTube channel that we have just started. Go ahead, show some love. Training versus inference. Now, you always come across this term in the media almost on a daily basis. And when you hear those great panel discussion, you have Jensen Huang, you have Fei Li, you have Jeffrey Hinton, you have Gary Marcus, you have all these geniuses come together. They throw these words like it's child's play, but it's not for 90% humanity, guys. Have some sympathy, show some love. So, what is training? What is inference? Very, very simple. Let's deconstruct it completely. Inside the AI company's lab, when they train a neural network, that is training. Once it is deployed, it is given to you. And you ask it a question, and it answers that question correctly or wrongly or hallucinating or whatever. Whether it's a text based question or an image based question or a video based question or an audio based question or a code based question or blah, blah, blah. That is inferencing. Now I come to a very interesting point. Why is NVIDIA so successful? Why is it racing to the moon in terms of stock capitalization and stock price and stuff? I don't know what happens tomorrow. It may crash. That's a financial discussion. We'll not go into the AI boom, bust, data center, energy. We'll talk about it later. The reason NVIDIA is doing so well is intelligence cannot be stored and invoked as copies. It has to be created on the spot. So you need a GPU to burn to create intelligence. Now I've given you food for thought. Think about it. And if you have something to say on it, say, but we'll delve into it later. I'm trying to seed your mind with powerful ideas. The good learners will see the value in it and their love will be with us always. So this is training and this is inferencing. Inference is when the model actually works. So it calls up the GPU or the CPU, or if it's Google, it will call up the TPU, and Google is going great guns. You know, for the past 3 years, I found people dissing Google, mocking Sundar Pichai, laughing at Sergey Brin, Larry Page. Google is done for. OpenAI will crush Google. I would always say it's impossible. Google cannot be crushed by OpenAI. Why not? Google owns the whole tech stack, top to bottom. Google owns YouTube. Entire humanity's data in YouTube is with Google for analyzing. Google owns Blogger, millions of blogs and data. Google owns Google search engine. 25 years of humanity's data neatly categorized, indexed, data based. Now, do you need anything more? All it needed to do was put everything together properly and marry it with the right AI and then present it to you. And that's how they did it at the end of 2025. And that's the magic people are talking about now, Nano Banana Pro or Notebook LM or Google AI Studio or Gemini 3 or what. So Google was never to be beaten, especially the chips, tensor processing units are also made by them. So no one is going to beat Google in the short run. It was a foolhardy approach. They just took 1 year and now the others are running for cover. Of course, you can disagree with me and you can always say, down with Google, evil company. That's your right. I cannot stop you from saying that. Go ahead and do that. But at least stop using Nano Banana Pro that. So you have inferencing here. I hope so far everything was cool and clear. We have done chapter 1, chapter 2. Now we come to the generative shift. This is the shift you and me are in right now. And if you're not a part of this generative shift, you'll miss the bus. I promise you, every one of you can learn AI. You can learn ML, you can learn DL, you can learn robotics even. You can definitely learn AI tools at a expert or even at an advanced level. It's not impossible. But all you have to do is please get rid of that fear. Watch the Matrix movie once. That classic conversation between Morpheus, the guru, and Neo, the protege. What did the mentor tell the protege when they were doing the jump test? It was a simulation. The bodies were outside, but Neo was unable to jump because the depth. You have seen Matrix. If not, watch it now. I mean, after you've watched this full session and shared it and liked it and subscribed it, after that. Otherwise, you will say, shut everything, I'm going to meet. No, 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 no. Morpheus makes a chilling statement to Neo. Morpheus says, you have to let it go. You have to let it all go, Neo. Fear, doubt, disbelief. Free your mind. This is what I'm telling you right now. You really have to let it all go. Fear, doubt, disbelief. Free your mind. You have chained yourself. You are scared of AI. You think it's something made by geniuses. Well, that part of it is true, but you can use it. Companies can adopt it. Education institutions, schools, colleges, universities can bake it into their DNA. But that needs a strategy, right? End to end strategy. You can't have a tool and just parachute it into your DNA. It doesn't work. That's why GenAI projects fail. The machine part of it fails, the data part of it fails and stuff. But you can learn it. All you need to do is get rid of fear, doubt, disbelief. Enough of filmy stuff. We get back to learning things. The generative shift. Chapter 3, we'll do segments 11, 12, 13, 14, 15. You are with me, right? Please don't go. Billion Buddy will be extremely sad. Ooh-hoo-hoo. What happened is we suddenly found that neural networks could end up creating things in a dazzling variety, which was unthinkable even for the creators of the neural network. Trust me, till 2016, nobody had an inkling that there would be a chatbot one day which will create images for you, text to image. People would have laughed at it. Of course, the godmother of AI wouldn't have Fei Li. The way she built up computer vision and the way she once told her proteges, can you turn text to image, and the way they were flummoxed, well, she saw it. But then 99% of humanity didn't. Generative AI is AI that generates. It doesn't discriminate. It generates. It can generate image and audio and video and text, of course, because that's their native capability. They're all trained on the text of internet. And it can generate code and anything you want. And now they are all multimodal. It was unthinkable 10 years ago, thanks to Google Transformer architecture and thanks to many other such innovations that now we are in this beautiful world with its risks. Yes, there are downsides. That's why we have the talk for regulation. Of course, this was the old AI discriminative. So you had to do a labeling and a decision thing. So this is a classification problem. This is a regression problem. Those of you who have studied it, no. Those of you who haven't, well, you have heard those terms today: classification problem, regression problems. But with generative AI, you ask it to do any kind of a wild stuff and it does it for you. So you are a manager and your project was to be completed today and it could not be, and you are spooked. So you go to Mistral or you go to Claude and you give a prompt. My project was to be completed today. I could not. I'm spooked. Convert this into 10 different proper pitch. One for my board of directors, second for my wife, third for my friends, fourth for my teammates, fifth for my other employees of the company, sixth for my immediate boss, seventh, eighth, ninth, 10 for the media. And Claude will say, your wish is my command, O master. And it will give perfectly suited 10 different pitch for 10 different audiences. Imagine the kind of training that Claude has undergone to be able to recreate such patterns. Of course, it has learned tens of thousands of patterns from the textbooks and the internet corpora that it was subjected to. Otherwise, it couldn't have done it, right? We understand it. People who treat AI as magical, they falter here. They think that this is magic. It's not magic at all. It has seen those patterns earlier. So it is collecting, combining, probabilizing it. And that's not a word even in English, I think. And it's creating probability maps and creating the answers for you. And you think it's magic. It's not magic at all. It's wonderful mathematics. Could I explain that more on it later? The autocomplete on steroids. All of us, I am truly a veteran because I saw the arrival of email. Imagine a man who saw the arrival of email. Yes, yes, we exist. Then I saw the arrival of mobile handsets. Yes, we exist. Then I saw the arrival of internet on mobile handsets. Then I saw the arrival of Orkut from Brazil. Then Facebook. Then the first time we had a proper instant messenger like WhatsApp. And we saw everything getting integrated, but there was no AI till then. It was all hidden behind corporate walls. AI came out once we had this autocomplete on steroids thing. Autocomplete was always there in the mobile phone, doing all the Siri errors and good things also. But the moment neural networks were applied on it, it could be autocomplete for image, for audio, definitely for text. This is autocomplete on steroids. Just remember that. So every time we talk about an autocomplete, we are actually talking about LLM minus minus. And every time we talk about LLMs, we are talking about autocomplete on steroids, literally autocomplete on steroids. So this beautiful thing explains the whole thing very clearly. Let me take a minute to explain this. So this is the most wonderful thing maybe you should do well, or you would do well, remembering. If you see this clearly, LLMs don't know facts. They predict the most statistically likely next word. And that's it. This is exactly what I've been saying. So those who think LLMs are intelligent or they have human emotions, no matter what purpose the LLM has been put to, eventually it is doing regurgitation of probabilistic maps from which it picks up the first word or the first token, most highly likely token, to come in the sequence using weather transformer architecture, which we'll cover right now. Don't be spooked. You will learn what it is. And these beautiful infographics are just an aid, just a guide for the serious student to go into. Otherwise, you can simply skip even these. So these LLMs internally, for every word, do a probability for the next word. And whichever comes there, they just spit it out. And that is it. Let me again simplify this before we even move ahead one step. Whatever inputs you give an LLM, large language model, which is an AI system, which is a chatbot, which is Gemini or ChatGPT or whatever, if you do a text prompt or you feed in an audio file asking it what was the genre of the music, or you feed in a video asking for classifying various segments of it. Some LLMs can do it. Some AI tools definitely can. Not all LLMs can. They all have their own personalities depending on the system prompts fed into them, guardrails and stuff. All LLMs have a personality. We all know when we use it. For example, some may have a very good sense of humor. Some may not have a sense of humor at all. It depends on who trained it, right? So whether you give a text prompt or a video prompt or an image prompt or an audio prompt or a code prompt, the first thing any LLM does, all of you should know this, it will immediately convert it to numbers. It will convert everything to numbers put them into very neat matrices or tensors, stuff that you never liked in your schools. But the entire world economy is running on matrix multiplication now. Imagine LLMs do what they do because they are able to multiply millions of matrices in a fraction of a second using those GPUs, CPUs, TPUs. If they couldn't, there would be no LLMs today. So they convert everything into mathematical notation, and those matrices then flow through the whole network. Whatever happens inside, if you're not planning to become an AI developer, you don't even need to know what happens inside, although I'll show you what happens there. And there are wonderful channels on YouTube which have actually tried to visualize it. I really admire their courage for having done that. Wonderful stuff has happened on the YouTube. People have actually visualized it beautifully. There's so much to learn. And when they come out, the answer, whatever it is, it's a classification problem or a regression problem or a prediction problem, is a number. It's a matrix. And then it is converted into the language of your use. So you input language, you output language, but in between it's only numbers, 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 nothing else. So LLMs only see numbers. If you input a text string, it will break it into small tokens, ratio of 3 is to 4 maybe, and convert it to numbers and immediately process those numbers. Brutal processing of numbers. And the GPUs and the CPUs and the TPUs do the wonderful parallel matrix multiplication. And there you have it. You have an answer. So in a simple language, did you understand how LLMs work? More you read about it, more you come across these terms, more is the level of comfort you build. It doesn't happen overnight. My advice to all young folks sitting there, young folks of 80 or young folks of 8, doesn't matter. It's here. The process of learning is all about really letting it all go. Fear, doubt, and disbelief. If you don't break those chains, it's all over. You might as well never have started. And if you actually break those chains, amazing things await you. The autocomplete on steroids concept, this actually helped us read and understand this. So you can make your own notes also, and maybe that will help you a lot. Is that clear? So far, so good. Billion Homes, AI for real impact, making some impact. I hope over the next few years, we end up creating a good impact in terms of learning outcomes from for people around the world. All my courses will be designed so that people from around the world can make the most of it. Your suggestions are always welcome. I will not go into any other technical detail, but I am just showing this for a few moments, allowing you to digest it and maybe just say, yucks, what a horrible thing this is. I'm never going to use AI again. Now, you cannot say that you're not going to use AI again is an impossibility now, seriously, unless you're a hermit. It's not possible now. Netflix recommendations are AI, boss. So, can I share a personal story? So, a few months ago, I was invited to an evening party at a beautiful farmhouse of my friend. So, in the evening, we went there. And my friend asked me, "So, Sandy, what are you into?" and all. And I shared, and he was aghast. AI has to be banned. That was his instant reaction. And I was taken aback, but I kept my composure and I said, "Yes, you are absolutely right. Let's start with your mobile handset." He said, "How?" I said, "Every single piece of software you can show me on your mobile phone will have embedded AI behind the wall, behind the screen that you cannot see. And if you really want to get rid of AI, let's first get rid of your handset itself." And then we went deep into the discussions. He had some very genuine concerns. Concerns on employment, agreed. Concerns on rampant energy use, which should be optimized, agreed. Concerns of super concentration of wealth and power in a few hands, agreed. Concerns of no regulation and hence a lot of misuse and all, agreed. Those are real concerns. We'll talk about that. We'll talk a lot about that. But at the same time, there are huge benefits to be reaped. And whether or not you agree or disagree with any part of this discussion, the fact is the revolution is upon us. And a sensible person would try to make sense of it and make the most of it in a legal, ethical, proper way to amplify his or her powers to be as empathetic as they were earlier, to never try to concentrate stuff just because you had access to certain tools. I believe that is the most human way to go about it, and I'm sure you'd agree. So this is autocomplete of Chirai's concept. We move one step forward. This horrible, terrible, deadly nuclear explosion you see on the screen is called the transformer architecture. And let me absolutely break the secret to you. This is what made the modern chatbot revolution happen. So, in a very simple language, what exactly was the transformer architecture? The attention mechanism, you must be reading these terms every day in blogs, and you must be hearing them in videos and talks and tweets and reels and on TikTok. So at least you should know what this is, right? So, because this is the foundation of all modern LLMs, let me talk to you directly and explain in very simple words what the transformer architecture was and how did the attention mechanism created by Vaswani and group inside Google completely revolutionize everything, including Google. Google Translate before the transformer architecture was such a pain. And the moment they deployed the transformer architecture, this is what I think, Google Translate became heavenly. So, what is it? So, let's come back to humanity. Two humans talking to each other. When we talk to each other in our language, we have words and we have the body language. And we talk to each other. We may be speaking long sentences, we may be speaking entire paragraphs, we may be speaking just a few words or doing just uh-huh, hmm, oh, ooh. There's a whole repertoire of such emotions built over tens of thousands of years, literally. And then there is the body language. You take everything together, it's called context. Language and communication is always contextual. This is why fake news, misinformation, disinformation peddlers first eliminate the context. Every fake news peddler, every misinfo or disinfo intentional peddler first eliminates the context so that it becomes poisonous. Communication without context is equal to poison. It can be turned in any which way. I mean, you give me any piece of communication and I can turn it to poison instantly by eliminating the context. That is the trick that these anti humanity peddlers follow. It's a very simple trick, actually, and the very deadly trick because social media has magnified the potential outcomes of such dastardly tactics a million times over. So people die in the real world. Earlier, the impact would be very limited without social media, but then you know that, right? So human communication is contextual. Without context, communication has no meaning at all. Two human beings, if they are together for a long time, they can just talk in gestures and symbols and they know exactly what the other person is saying because there is a whole backstory of countless communications which have been encoded inside the neuronal networks in the heads. So there are complicated neuron networks which have encoded all this. So that's how gestures tell stories between two humans who are very close. But the machines have no such ability. Till 2016, they literally had nothing. So when they would predict the next word in a sequence, they would look at the previous word or the previous two words. And you know that can be very dangerous and definitely very limiting. The day innovators and inventors and scientists were able to crack this idea that I should not just be looking at those two words, but the next potential three, four, five, six words, and maybe even other sentences. And I should pay attention to all this. Attention is all you need. That classic paper was published by Google scientists, including, as I said, Vaswani and others. And it totally changed the neural network story because now the answers were much better in a human context because they looked at a broader context before answering. That's it. That is the transformer architecture. So there is a mass behind it, there's a lot of technology behind it. But if you're a non technical person, this entire Billion Hopes thing is for people who are beginners Non-technology professionals, strategists, you don't need to learn the transformer architecture at all. But just in case you want to show a horror story to somebody, here it is. This terrible horror story you see on the screen, which can actually qualify as a horror flick, absolutely, it should be put in the horror genre on Netflix, is the transformer architecture, the attention mechanism. The name of the paper was Attention is All You Need. Such a fancy title, beautiful title. I went to the bank to fish. Now, bank could be a financial bank. Then it would be to deposit money. If it is a river bank, it could be I went there to swim or then I went there to fish. This is the importance of context. If the LLM can look at a larger picture, then the outputs would be less likely to go astray. This is the attention mechanism. So you can do self attention, cross attention in the feed forward networks. Don't worry at all if you don't know what is a feed forward network or what is backprop. It doesn't matter if you don't know it. Maybe you'll never need to know that. But because the words are relevant here, so I thought I will just speak it out once. Maybe you can choose to not even hear. How funny it is, right? We cannot choose not to hear. We have to hear unless we really close our ears tight. So you have an encoder mechanism, you have a decoder mechanism, very complicated things. Absolutely. You don't need to know that, but you just need to know that in 2016-17, there was this massive innovation. And this is the technical story, but there is another very cunning story behind it. I'm sure you are interested in cunning stories. Google was the one that stumbled upon this transformer architecture, actually innovated it. Stumbled upon is like not a good thing to say. But the first company, the first man who saw potential in it was not Google or Sundar Pichai or Sergey Brin. It was Sam Altman of OpenAI who immediately used this to improve his models. And he had the whole game ahead of us. He knew he had to release it in the public as a consumer chatbot. No other company would have done it the way Sam did it. Given Sam's corporate background, Y Combinator stuff and all. So Sam Altman took this transformer architecture and used it. I'm putting a complicated story in a very simple way and used it to improve. And Google just kept looking at it, gawking at it. And years passed by and Google was behind in the race. Then after 2022 and 23, Google said, hey, I own YouTube, man. I own the Google database, the Google database, man. I own X, Y, Z, I own it all. I'm just going to connect it properly now. You just wait and watch. And then you know what happened, right? We'll talk about that, what happened. So this is the very cunning and interesting story of the transformer architecture. But then it came from Google. So let's give credit where it's due. Parameters and the brain size metaphor. This is one of my favorite topics. I've been doing a lot of reading on brain. I'll suggest some books to you. Maybe you would also like to do that. So now would you want to see some good books on AI and ML? In fact, the next lecture in this beautiful masterclass playlist is all about the books. I'll show you tens of books I have, actual physical books. I never recommend books until I have them in my personal collection. I never recommend books that I haven't read. A lot of people do that with so much confidence. I really admire them. I call them the living, walking, organic LLMs. They can speak on anything even without having read anything about it. Amazing. I wish I had that confidence. But it's a skill. It's truly a skill. So the next lecture is all about books. I'll show you many, many books on AI/ML. I'll show you all the good blogs and the good video channels. You should follow YouTube channels. Papers, at least the top 50 AI papers that you should know about in a very, very non-technical way. But where were we? I forgot. Okay, the brain size metaphor. So now I'll show you a very good book on brain. So if you know nothing about brain in context of AI and ML, the first book to probably start with is this wonderful masterpiece by Max Bennett, A Brief History of Intelligence. This is such a wonderful book. It will tell you exactly how the human brain became what it did over 650 to 700 million years, step by step, the various 5 or 6 phases of evolution. And once you have read it thoroughly, made your notes, I always read books. I prepare my own notes in it. I prepare a separate notebook. I'm a great handwritten notes fan. I love making my notebooks, writing notes with my own hands. I love it. Although my handwriting is not too good, but I think my learning and retention is much, much better when I invest time in doing that. Maybe some of you will follow it, maybe some of you not. This book will tell you exactly how AI will evolve from here on in a much in a much shortened time scale, or on a very different time scale. This is a good book to start with. I recommend this. I'll be recommending hundreds of books as part of the Billion Hours project. So maybe this is what the brain thing will help you. So why did I even bring it up? Because now we are talking about parameters. What exactly are parameters? So let's see what exactly are parameters. So once again, we need to understand it from the basics. And learning about brain and how it works is a passion that I share with many people, in fact. And it's good to see so many. And the research is amazing, the kind of things that are being researched about the human brain and stuff. The human brain has 85 to 100 billion neurons. Each neuron has a connection with many, many more neurons. And where they interact, they do not touch each other. An electrical signal passes through, which is called a synapse. And the neurons will have hundreds and hundreds of synapses happening simultaneously. There is a biochemistry and electrical system of synapses happening, the pulse rate, firing rate, and stuff. But the simple rule is more are the interconnections in a brain, the more evolved is the ability to handle complex problems. So if you have 86 billion neurons in your head and they are interconnected very densely, putting it very crudely, the whole thing, I'm simplifying it, you will be able to solve problems better, analyze better, think better, reflect deeper. And the poorer are the internal connections of the neuron, which could be biological problems, which could be the nurturing problems, poor childhood problems. It is absolutely true that if in the first 5 to 6 years the child unfortunately is not exposed to the right learning environment, the right physical nutrition, the brains actually can remain underdeveloped. It's an absolute tragedy with millions of kids around the world. And then in the later adult life, those connections never grow to the fullest of potentials. But the simple logic is the more dense or the denser are the neuronal connections, the better is the brain's ability to function. So scientists knew this. So the AI and ML experts picked it up and they said, if we have one layer of neurons and we try to give an input and extract output, it doesn't work ever because the number of interconnections are so low. So let's make 2 layers of neurons, say 5 each. Then they found that with complicated patterns, those 2 layers were not working. So they added a 3rd layer and a 4th layer and a 5th layer. And suddenly magic started happening because the moment you add more layers of neurons, which are mathematical constructs, the neural networks start interpreting complicated patterns better. So that is why today's LLMs have hundreds of layers, millions of neurons, billions and billions and billions of parameters. And what are parameters? Very simple. A weight and a bias. Add them up, that's your parameter. Every artificial neuron has a weight and a bias. It's a mathematical equation, simple. What kind of maths is used in neural networks? Linear algebra, regular algebra, geometry, calculus, probability, and a lot of statistics. That's it. That's the maths which is used. So if you're planning to get into it technically, these are the 6 subjects in maths you will have to study. If you're not planning to get it into technically, you don't need to study any of this. Not at all. So this beautiful infographic explains it, that just like in the biological brain, greater are the interconnections and more is the intensity of the synapses, better is the ability to perform for the brain. Similarly, in an AI model, more and more are the number of layers. So more will be the neurons, more will be the parameters. So the next time you hear Sam Altman or Sundar Pichai or Sergey Brin or any other chap, Mark Zuckerberg of Meta, Llama series of models, talk about we have had a 500 billion parameter LLM, So all these LLMs, you're listed, you always read 2 billion parameters. It's a small LLM, just 2 billion parameters. It's a large LLM. We have 800 billion parameters or whatever. I mean, I'm just throwing random numbers, but they are mostly in the ballpark region. What are these parameters? Take all the weights, take all the biases, add them up in every possible permutation, and you have the total number of parameters. Is that clear? So if you have more parameters, the LLM can actually understand complicated non-linear subjects also. Otherwise, it cannot. It is exactly similar to the brain in at least this conceptual way. So now you know what parameters are, at least at a first level. So now you are asking me, why do these stupid things hallucinate? LLMs, the stupid things, why do they hallucinate? Well, they hallucinate because of a very fundamental reason. And that reason is they are designed to hallucinate. What? LLMs are designed to hallucinate? That's a criminal act against mankind. I'm going to report it to the police. Ooh, ooh, ooh. Hallucinate is not a negative word. Hallucinate in a crude way can be to imagine. So what do LLMs do? They imagine the next word. What do human beings do? We are literally hallucinating every moment. We are imagining the next word, the next sequence of events about to unfurl before us in this extremely complicated 3D world. None of us know what happened. I mean, this entire ceiling could fall on me the next second. And that's the end of this video. Imagine. Do I know that will happen? I don't know. So I imagine things. I hallucinate. That's again putting it crudely. So please forgive me for that. LLMs are designed by law, a technical law, to predict the next word, period. If the probability is low, it will still predict it. If that low probability is the highest in a set of probability. So they will hallucinate. Now, at times, you might ask a very good question. But if the LLMs are trained on such a huge data set and stuff, why do the LLMs hallucinate even then? Well, there were a lot of gaps in the training data. And the LLM, the chatbot or the neural network, was not exposed to enough of the right patterns. So suppose I make an LLM. There's a very good book I'll be showing you right now that explains this thing from the root cause. So suppose I decide to create a neural network, a small neural network. You can do that online. There are facilities available. Free of cost, you can do that. You can test it, increase the number of neurons, layer, do that. Keep experimenting. They don't ask for any technical degree to be able to do that. So suppose you build a neural network and the only data you feed it is that the capital of America is New Delhi. So that neural network is exposed to only one truth. The capital of US is New Delhi. If you ask it that question, it is going to spit out New Delhi because it hasn't seen the truth at all and it is not a truth engine at all. So in the sequence of probabilities, New Delhi will sit at the top and maybe some other cities close to the right answer will come right below, but then it will have a propensity to throw out New Delhi as the answer. So you cannot blame that neural network, can you? It was the human being who gave it a wrong training data that ended up causing a disaster. So very good book that captures this amazing story is by Generative. And she explains beautifully, you look like a thing and I love you. When you actually start training any neural network or a machine learning system from zero, the kind of absolute nonsense it spits out initially is hilarious. You look like a thing and I love you by Generative is a book you might want to read one day to realize that there is no magic behind machine learning and AI. It's absolutely pure mathematics. I'll keep recommending such books. So why AI lies? AI is not telling you a lie. It doesn't even know what is the truth and what is the lie because it has no soul, no heart, no conscience, nothing. All AI is doing is it is a probability engine and it is throwing out an answer based on the training data it received. And the assumption is that the human being using the LLM data is exercising discretion, which in this world of today is truly speaking a long leap. So many of us have literally given up using our discretion. This is an absolute warning for everyone watching this. Cognitive offloading will kill you. Take it as a warning written on stone, cast in steel, whatever. Cognitive offloading will turn you into a vegetable and kill you. If you're a student, if you're a professional, if you're a homemaker, if you're a teacher, whatever, use LLMs as aids. Do not offload your thinking to them, only disaster will follow. I see it in my own team. I have seen it across companies. When the first recourse to finding an answer to a question is an LLM, inevitably disaster happens. ChatGPT can give completely wrong answers with full confidence because that is the data it has been fed. And you end up going down the garden path. And then after 2 days, you realize you were chasing the wrong goal. The right way is this, but you never even stopped to think about it. The urge to offload your cognition onto a machine, which itself has no cognition, is so strong that people are literally killing themselves. Please, for your sake, don't do that. Always, when you're confronted with a question, first think, then use an LLM as an aid, but keep your degree of skepticism high. Because I've been an entrepreneur for more than 3 decades now, I can vouch for it. Nothing beats original thinking and original ability to be a skeptic. If you're not that, seriously, LLMs will harm you. And then don't blame the LLMs. They never asked you to do cognitive offloading. I mean, you chose to be a vegetable, not the LLM. They did not force you. They cannot force you, actually. So is hallucination clear at a basic level? I hope it is. Good, good, good. I tried to explain it in one way. Of course, there are technical shades. Of course, there are 10 more things to be discussed. But that's not the goal today, right? Hey, that's great. We have reached chapter 4, the modalities. Natural language processing, computer vision. Wow, AI has started seeing things. Image generation, audio, video, or audio and voice cloning, multimodality, which is the holy grail, and we are almost there. So, are you enjoying the session? Are you enjoying this masterclass? Are you enjoying Billion Hopes content? So, this is just the beginning. Over the coming weeks, months, and years, we are going to do a lot. You are the key. Keep supporting, ladies and gentlemen, boys and girls. So, now we come to natural language processing and the modalities. Shall we begin? 16 to 20. Natural language processing, one of the most complicated topics in AI, is all about talking to machines. Earlier, there used to be command lines. Only technical experts knew how to do that. That deadly black screen and that absolute gibberish that people would type in and others would just gawk at it like idiots. 10 minutes ago, I told you that the reason ChatGPT became a rage, it actually allowed an average human being to talk in their language with a machine. It never happened in history before. And that's why you have billions of people using LLMs today. But there was a middle phase also, which was the graphic user interface of Windows or the Mac OS. And people started interacting with the graphics. Now I have seen even that phase. Imagine, we used to do DOS. There was a DOS once upon a time, disk operating system. And I still remember the computer vendor I had in those times, 80486 and 80586 processor, he said, we now have Windows. And I said, what is Windows? Sorry for sharing that. I mean, I know you are spooked, but that's how it is. What can I do? So, graphic user interface, when it first arrived, it was a revolution because people actually saw things visibly, but they could not talk to it the way they are talking to computers today. So, this is how the transition has happened. It's a wonderful transition. So, you can ask me, what will be the next step of it? Telepathy? I don't know. 10 years, 20 years, 30 years? I just don't know. We'll all have to wait and watch. Anyway, let's not speculate. So, English is the hottest programming language. Natural language processing and English is the hottest programming language. So, what do we mean English is the hottest programming language? Vibe coding in January, February 2025, the genius named Andre Karpathy actually wrote a tweet saying, I was just giving instructions to LLMs and he is the one behind so many LLMs. And I think this vibe coding is good. And people so loved the term vibe coding, it became an industry. Now we know there are many limitations to that. So they are now talking more about contextual vibe coding, which is actually a right term. So vibe coding is all about telling a computer in English or in any other language, I want to build an app which does this, and which does not allow this, and the user interface should look like this, and the database should look like this. Can you code it for me? Yeah, Wish is my command master, and cursor will go, or so many other vibe coding softwares, or the LLM's native coding abilities. Some of them are really good at it. They will start, and the machine will start worrying, and you have a full code base ready for you. Of course, implementing that code base, ensuring all the dependencies are met, when the real world edge cases are felt, everything collapses at that time. That is the moment of truth. Experts know that. For the beginners, it's a good experience. People see that and then they learn, ki, okay, I need to do this. But English can be used to code. So that natural language processing ability in computers is truly a big deal, because processing natural language is not easy. So you'll ask me, how not easy it is? This not easy it is. So this natural language and speech language processing book, this is a textbook, proper textbook. I mean, this if you, it's a horrible book. You scan through the pages, you start losing faith in humanity. It's that tough. So NLP has never been easy. Human language is not an easy thing to understand at all for non-humans. And so when humans try to explain it to non-humans, that is machines, it is an even more difficult thing. So mathematics and statistics comes to the rescue, and then you have NLP experts who really are technically very qualified people. So what I just showed you was a book by Pearson, Jurafsky, and Martin, Speech and Language Processing by computers, of course. So that was a big deal, and we were able to do it. So today's LLMs are experts at this NLP based coding. And they take your language, turn it to numbers, turn it into tokens, feed it to matrices and tensors, and then throw out the same thing, which is turned again to your natural language, which you can understand. Otherwise, you only had one option. Imagine if today Sam Altman and OpenAI tell us, from tomorrow you're going to see this black screen, and this is how you feed a prompt. Can you see this in this computer language? People will say, hey, goodbye, Sam. It was nice knowing you. Goodbye. See you. Have a nice life ahead. You know that, right? Computer vision. So we have understood the first part, what it means, and now we come to computer vision, how AI actually sees. Well, once again, sorry to break the bubble, AI doesn't see anything in the human sense. When you and me see things, we actually see the three-dimensional world in which we are physically immersed. When we hear anything, same. When we touch anything, when we taste anything, it is part of a 3D existence we enjoy. Machines and computers, even robots, do not have that sense. So that's the debate on consciousness and qualia and sense of self and willpower and free will. So that's a huge debate, ongoing philosophical debate for centuries. We'll not go into that in this lecture. Maybe if you want, someday I'll create a full lecture on that or a series on that, maybe. How do AI or computers actually see? All that they do, the wonderful new computer vision systems, all they have done is, I mean, Fai Lee, as I call her the godmother of AI, she was the first person who actually institutionalized computer vision the way we know it today. We think it's so trivial. You should go and ask that lady how she actually created 22,000 categories of objects in this world, millions of overall images, and every image labeled by hand by some human being. This is how computer vision, modern computer vision, was created. Isn't it maddening? The persistence of these people, they did it. And then neural networks were subjected to those millions of images labeled. You remember supervised learning? And across 22,000 categories, and neural networks were trained to recognize patterns. That's how they learned to see. This is the TLDR, the long story short. There's a beautiful book by Fai Lee, The Worlds I See. What a beautiful title for her work. So I'll discuss that book also in the next lecture in this series. That is what the next lecture is about. So you break everything into pixels. And then there are specific algorithms. You'll have a convolutional neural network or some other variant of it. And they have followed what the human eye and the human brain does. It is long known that the neurons, I mean, the whole eye is called half the brain because the eye itself does so much of interpretation before it feeds it into the optic nerve and then the visual lobe and all the back of the head, they do it. And one of the specific properties of the human brain that makes it so wonderful is that if a particular part is damaged, the other part can actually, given the right stimulus, pick up that skill. It's unbelievable, right? But the human brain is that plastic. So go through that book by Max Bennett and you'll be surprised to discover such stunning facts. That's how even AI progress is now happening. So our visual system actually does a lot of things that we just do not know. It happens subconsciously. I would even go to the extent of saying unconsciously. We don't even know. The edges, there will be a set of neurons that will detect the edges. The colors, a different set of neurons and stuff. So everything will be broken up into specialized functions. And the neurons will do that. So they actually developed algorithms. Once again, you'll have to forgive me for simplifying things a bit too much here. Those of you who are technically qualified will be very angry with me. I know that. But then I invite you to do this in for a general crowd and in a simpler manner. Detect the edges, shapes, and then collate everything together to make a final object. Any error on the infographic is all mine. Please excuse me for that. Any image is broken up into a massive grid of pixels. And then it's a play of pixels. You remember I told you a secret of neural networks? Divide to conquer. Any task, they divide it at a pixel level. That is their secret of success. They divide to conquer. Whether it's an image or a video or text or audio or code, they just divide to conquer. That is what neural networks do. And the problem is the black box and the lack of explainability, which is not going away anytime soon because it is the whole architecture. Imagine we humans don't know how we learn. We know the process of learning, but the algorithm in the head, it's not known. We couldn't even crack C. elegans, the worm. So you might be wondering, what do you mean we haven't cracked it? We know the exact neuronal structure. The challenge is to recreate it, right? We cannot. And as long as we cannot recreate it, we haven't understood it. It's only the process of creation that actually brings understanding to the fore. So this is how you see. Now, once computer vision is cracked, I mean, so many things become possible. Medical imaging. In advanced nations or developing nations, expert doctors are always under a lot of stress because everybody would want to consult them. So, how many X-rays or MRI reports or CT scans can an expert scan? So, machine learning systems have become extremely good, at least in underdeveloped or developing nations, to churn out, to handle massive workloads every day where nothing could have been possible earlier. So, for example, in a remote region in India, in a small village, there may be no expert doctor. But in a cluster of village, there might be one doctor. And if he knows machine learning, people can approach him. And that guy doesn't need to consult someone big from a metro, and he can just pass it through machine learning software and identify whether there is a cancerous tumor or not. And then consult a senior. Of course, there are risks in it. I completely accept there are risks. But you will be surprised to know that surprisingly higher degrees of or high degrees of accuracy are now being achieved in medical imaging. Surprisingly high degrees of accuracy. And for people who have no option, this is not a bad option at all. I know it, there are problems, but it's much better than not having any diagnosis at all. Yes, there are false positives. Yes, there are false negatives. But there are solutions now. Self-driving is all about computer vision. There's nothing in self-driving except vision and then the manipulation of that vision. So if you have Waymo taking over the world or the Chinese taking over the world in terms of self-driven cars, it's because they have the radar or the lidar or the camera and they add up everything. They create a 3D model of the world and the car accordingly does it. And there's a lot of reinforcement learning also. We have talked a lot about reinforcement learning. Would you want to see that Bible of reinforcement learning that I referred to? Rich Sutton and Andrew Barto? Why not? Let me share that book also with you, although I will discuss that at a greater length in the next lecture. So, dear friends, here is that Bible of reinforcement learning. So, you have Rich Sutton and Andrew Barto, RL, reinforcement learning. Beautiful courses also on the net. I did one of their comprehensive courses in RL. It was very tough. RL is tricky. And Rich is the guy who actually has understood truly how reinforcement learning in the future might guide the entire progress chart or the map of AI. Because LLMs have run out of data and synthetic data is not helping, and AI slop being fed to AI will lead to model collapse. So this was technical charge. So that's why Andrew and David Silver, they have suggested that we should have real-time sensors from the real world feeding data, and that's the only way ahead if AI has to improve. So that's for another day. If you know more about it, share in the comments. Make sure you like and share and subscribe and all that stuff people do. You're good people, you will always do it. I'm absolutely certain. Image generation. This magic wand, all of us use it on a daily basis now. This is normally the forte of diffusion models. You remember this used to be a TV way back in 60s, 70s, and 80s. You switched on the TV, now you get a YouTube directly. But earlier we used to see this absolutely noisy environment, static. Now, the diffusion models have actually devised noise and then they do denoising or the reverse process. This is how we see it on the screen, right? Now, some ultra fast models like Google Nano Banana Pro, you actually do not even see the diffusion process or the denoising process. They are so fast. But with ChatGPT, at least now, you actually see the diffusion process happening. Maybe in the future, they'll also become very, very fast at it, depending on how the compute is actually leveraged. So this is the denoising process, and the image slowly comes into picture as pixel by pixel, the noise is removed. So this is how image generation is actually done. Is that clear? But they are trained using real images. And there is a reason why this entire process has been created. Reasons of optimization, reasons of so many other things. But that's another full topic in itself. All you need to know for now is when you give that very humble prompt, can you create a beautiful image of a sunset and place me there in the sunset, there with my friend, sipping a cup of tea or coffee or whatever other delicious things that you do, and the hues, this and that. So, what's happening is diffusion here. I hope that's clear. I'm certain the next time when you do it, you're going to think it technically and some juice will be gone. Audio and voice cloning, and then we'll come to multimodality, which is like the holy grail. And it has happened right before our eyes. Amazing things happening. Audio and voice cloning. So that's called TTS, text to speech, or you could have speech to text and cloning technology. So this is a real headache now. It's an absolute nuisance. You can not only clone people's images, you can literally create videos of people with absolutely fake voice, which resembles the original voice, and deepfakes thereby become a real menace to humanity. So, a global AI regulatory model is needed. Having said that, I do not think it will be possible for anyone to stop the onward march of AI, bar a complete ban on it. Elon Musk tried it. They actually formed a consortium of people who, in the earlier 2010s, proposed a complete ban till humanity found a way to regulate it. In fact, you will be surprised to know that in the early 2010s, there were talks about AI never to be connected with the internet, otherwise, it will be a humanity killer. And imagine, ChatGPT was launched on AI, on the internet. So when the first launch of ChatGPT happened, I actually had a hearty laugh because I had read books like Life 3.0, which had repeatedly warned that AI should be sandboxed. It should not be released on the internet. And everything is on the internet now. So humanity has a lot of confidence in itself. It's a boon and may one day be a pain. I don't know if I live to tell the story 10 years from now, 20 years from now. Maybe, who knows? Billion Hopes channel will have my clone teaching you. In fact, Or are you really sure it's the real me here? Hey, did I say that? Editor, could you please just edit that out? We don't want them to know that Sandy is working there. He's on a vacation. Cut it out, cut it out, cut it out. Audio and voice cloning, text to speech and cloning tech. So, we know very well you can actually make AI speak things. I mean, they are doing it. You are interacting in voice. In the developing world, and especially in countries like India, where a very large majority may not want to type in anything for whatever reasons, Google figured out several years ago that audio is the way to go. Now, everyone else also has figured out. And the way they have given generative AI for free, India is literally their test bed. So, this is a good point I want to throw to all my students and dear friends watching this. Generative AI given for free to this entire beautiful nation of India. Is it good? Is it bad? Why are they doing it? What will they gain from it? What will they lose from it? All views welcome. It's a wonderful topic. And almost everyone is correct on it because there are so many views. That's the beauty of new topics. Everyone is correct. So, voice cloning, you just take a few seconds of sample of any person's voice and you can literally clone it. So now you can ask me, how does the LLM do it? I have told you, divide to conquer. It will take that voice sample and it will chop it and 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 find the pattern in. Earlier, the language experts and the linguists had a very different idea about how to teach human speech, voice to computers. They would find basic speech patterns, try to train them, but that was a very clumsy process because you need expertise to do that. Now I am opening up the next secret of LLMs to you. LLMs do not need any human domain expertise. That makes them so powerful and so dangerous. You don't need a linguist now to teach LLM how to recognize human language or English language, for example, or French. Using the neural network and given enough training data, it will find all the patterns by itself. And you will not even know how it did it because the black box problem and the explained problem. So domain experts to that extent become less relevant. Yes, in the training period, you need domain experts to verify or check the veracity of the outputs from the neural networks. Are you able to see what I'm trying to say here? So divide to conquer, get into it at the pixelated level. So that is why, I always tell my friends in informal conversations that the LLMs, or rather the neural networks, have now divided our 3D world into the tiniest pixel imaginable. And they are now playing with pixels so they can play with anything. And this is actually true. Human beings haven't evolved on pixels. Let me just make it very clear. We are creatures of approximations. Our parents, their parents, our entire lineage, the forefathers, thousands of generations, largely past 50,000 years, and in fact around 3 to 400,000 years, we have approximated the world around us. I mean, in the electromagnetic spectrum of radiation, we only see the visible light. We don't even see anything else. So there's so much happening around us, I can't even see. This is approximation. I can't taste everything. There are so many taste patterns which the human tongue doesn't even know. So many colors I can't see. So many things I can't hear. I have a limited audible range. There are creatures on this planet that can hear at a sub or an infra sub or at a higher level, ultra level. We are creatures of approximation. Our spatial orientation is approximate. We do everything basis approximation. That is the root cause of optical illusions, which is what magicians use. The entire magic industry in the world, which incidentally includes politicians also, is based on creating optical illusions. And our minds believe it because that's how we are. If human beings hadn't approximated reality, we wouldn't be here. We would have collapsed millennia ago. We would have gone stark raving mad. So we are creatures of approximation, living lives approximately. Comedians, magicians, and politicians have actually figured that out. Smart chaps. They are LLMs in flesh and blood, I say. So there are risks, of course. But now, if you look at Google Notebook LM, it is so advanced now, it actually creates an audio podcast for you. How does it do it? These are the fundamental tricks. Of course, much more advanced, but this is a fundamental trick. So, am I making sense to you? I hope I am. So much of effort, man. Come on, show some love there. Multimodality. This is the holy grail. What is multimodality? Oh, come on. Now you know that, right? Multimodality is very simple. I give an input of text, some documents, some pictures, and even an audio to an LLM, and I ask it to create a story around it. And that LLM I just named a minute ago. And the LLM says, "Your wish is my command, oh master. I am at work." And it starts working. It doesn't make any noise while working. It's only the fan of your computer that's making the noise. It's not the LLM. That GPU cluster, TPU cluster, there is making a lot of noise. So they need so much of cooling, damaging the planet's environment. Agreed, completely agreed. It's a serious crisis. I don't know what the solution to that will be. The best brains in the world are trying to find ways either to solve it or do more of it. I don't know. So, multimodality is when, just like a human being, right now you are watching me, you are listening to me, you are probably making your notes, you're probably even looking left, right, you are also eating something, you are being informed about certain things, you're feeling hot or cold, everything is happening in parallel. That's what life is all about. So LLMs end up mimicking that to some extent via multimodality. Is that clear? This is the convergence of senses. That's it. So this heavy sounding word. One thing my lecture today is definitely going to do, it is going to give you the superpower of never getting fooled by anyone who uses such words. So till yesterday, you might have considered a gentleman or a lady using the word multimodality as, oh, what a genius, multimodality. And now you know multimodality is convergence of senses. That's it. And you are thinking, that's it. So I was actually impressed by that guy when he said multimodality. What a fool am I? Multimodality is just convergence of senses, which I already am. That's the beauty of demystification, my dear. That's the beauty of demystification. Is that clear? As I said, some of the infographics may have textual errors. You'll have to really forgive me for that. Multimodality is still a work in progress. So, is our brain multimodal? Absolutely. This is why the brain has dedicated regions, some doing audio, some doing video, some doing taste, some doing touch, some doing motor control, some doing subconscious processing. If you really get deep into all this, you end up finding very strange things. You end up finding that the physical anatomical structure of this brain is such that a lot of inputs you are taking in are actually filtered by some physical structures before they are even passed on to the frontal cortex, which you mistakenly assume is free will and analysis, but they were already filtered by a very powerful structure. Can you name that structure? Without which you wouldn't exist. And anything threatening, frightening, dangerously abhorrent is already filtered out. And only the filtered stuff reaches the frontal cortex. That's one line of research. So that raises a lot of questions on free will. And free will is one of the big topics of philosophical debate worldwide, as we know, and we should keep debating that. So, multimodality is the holy grail. Wow, we have actually covered 4 chapters. I never thought we'll do that, but we have done it. And to all the brave souls who have stayed with me till now, I truly admire you. You actually listened to all this. I mean, I don't know whether I would have. What am I saying? This is the problem with clones. This. You don't train them well. This is what happens. How can a clone talk to itself like this? Is this matrix? Is there a glitch in the matrix? So there's this very interesting topic. Are we all in a matrix? So one doesn't know. On the YouTube, you will find a whole set of videos actually proving we are in a matrix. They have proven it already. They know they are in a matrix. Admire their confidence, man. I mean, cool. And then there are people who have actually explained why we are not in a matrix. And then there are folks like me who are looking wide eyed at both the camps and thinking, what should I do? Where should I go? But there was this one very interesting explanation I found in a book as to why we are not in a matrix. The explanation is very simple. Anyone who has played a video game, a matrix would essentially be a simulation, a video game that some giant creator has put all of us guinea pigs in. So that book made a very nice argument. I'll put it in a very simple word. I hope I'm able to explain it well. That book said, if this was really a matrix, we would be witnessing some very strange things every day. Because in a video game, which is actually a matrix simulation, you always see something breaking, a character suddenly jumping, a land suddenly vanishing, even with the best of GPUs processing things behind. You find breaks, chinks in the armor. But in the human life, you never see a man jumping 50 feet or land cracking without any earthquake. You don't see that. So we are not in a matrix. Actual argument was far more nuanced. No, the audio is still there. So now we come to chapter 5, the invisible eye. AI. You remember the farmhouse my friend invited me for a nice evening and party? AI should be banned. You remember that? And the way I tackled it after being taken aback for a moment, what did I say? Remember that? I said, absolutely, we should ban AI. Let's start with your phone. And then a long and a very fruitful discussion followed, where I explained why banning AI now is not a solution at all. You're literally immersed in it. And he agreed finally, although I also agreed that AI has a lot of downsides. And given the fact that most of the world governments aren't really talking about disruptions in society because of AI, I find it pretty silly that citizens are allowing governments and politicians to get away with it. Actually, citizens should push back. They should tell the politicians, why do we even need you? We might as well have robots and AI systems run the government much better. Why do we even need you at all? So if you don't care for us, well, that is our pushback. And this argument also can be taken to a very deep level, but then fine, this is the starting point. So now we talk about the invisible AI. And what is the invisible AI? Invisible AI is AI that you and me participate in every single day. We may not even realize it, but we do it. So, shall we start? We are going to talk about social media feeds, recommendation engines, navigation and logistics, digital assistants, email and search. You and me have been training the ML models for free of all these giant companies sitting on valuations of trillions of dollars for decades. Every time we actually solved that captcha riddle, some machine learning model somewhere was being trained by you without getting paid for it. Absolutely. One of these days, you should really approach Sundar Pichai and tell him, hey, boss, all the captchas I have been filling for the past 25 years and wasting my life, I have wasted 173 hours filling all your captchas. Where's my $1 million? Imagine if 1 billion people email Google demanding compensation for filling captcha. Just imagine. Google will say deactivate and just please get real. Anyway, I hope I could bring a small smile there on your very serious face. So let's start with social media feeds, the algorithm. And what exactly is happening and how are we feeding it and how with social media actually creating an alternative universe for us because we asked it to. Let's see. So now let's begin understanding these things and how AI has actually gotten interwoven with our lives so much that we just cannot separate ourselves from it, and maybe we wouldn't want to someday. We start with social media feeds. All of us know that the way the social media is designed is to serve the ultimate purpose of hooking us onto it. And yes, there are problems. They end up creating our echo chambers and they keep feeding us stuff that we like more And at times on platforms like X or Twitter, if you post something, it'll perhaps try to target those who are likely to oppose it. So, which is kind of creating a rage bait for those. So many things are happening. Ultimately, the private companies work with the goal of leveraging AI to maximize interactions on the platform. So, what is happening behind the scenes? Let's try to see social media feeds. So, engagement prediction is the word that comes up, and AI will keep you scrolled and hooked. And unless and until you have a mental filter that cautions you against it, chances are that you are going to be completely a victim, or rather, a subject for these companies. I use that word with caution. Every click or every second that you spend on that platform is being logged. So, for a normal human being, it is difficult to fathom how they can log everything. But then, if your webcam is on, they can even log the expressions and the way the eyes, so they can create heat maps of which part of the screen you watch for. So, things have really moved to that level. And that gives these companies a kind of quote unquote superpower to keep showing you things that will make you not leave. So your actions are the data fuel. Now, please recall what we studied at the beginning of today's masterclass. Data is everything. If you don't have the right quality of data, here it is the real time, refined, subject specific data. So this is a gold mine for these companies. And at a microscopic level, they have billions of gold mines working for them every day. I'm referring to you, your habits. So your actions are the data fuel, scrolling, liking, sharing, watch time, even the eye movements or the emotions, whatever they are. And everything is fed in real time via the cloud, or rather via the internet into the cloud, which is nothing but a physical data center. Anytime you hear anyone say cloud, it actually means a physical location where 10,000 or 100,000 servers are all neatly linked up, and they're connected with your handset via the internet and a Wi-Fi unit or the LAN or the cabled internet. Ultimately, there is a physical location with thousands and thousands of servers and server racks. That is the cloud. There is nothing in the cloud up there. See, you didn't know that. I had to explain. This is a beginner level course. I told you AI for real impact. Then there is an algorithm, which is the AI prediction engine. What will it do? On an absolutely microscopic level, it'll analyze all the patterns, it'll predict engagements, it will rank the content as seen with your eyes so that you can only be fed things which you are likely to engage with more and more and more and more and more. So that is why if you are watching this video and if you do not like it, do not share it, do not subscribe to the channel, then YouTube will say, Mentor Sandy's videos are not good enough. Let's not even push this. Because if we push this, ultimately people will not like it. And so, what will happen to Billion Hopes? So, my dear friends, keep the hopes alive. The output is your personalized feed. And this is all happening at a microscopic level on a per second basis using the LLMs, keeping you glued. You should not go anywhere because there's so much competition between the platforms. So YouTube is competing with Facebook, is competing with WhatsApp, is competing with TikTok, is competing with Instagram, is competing with blah, 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 blah. And that makes these really greedy for your time because attention is all you need. Aha. Remember what was attention is all you need? The revolutionary paper that actually gave the context superpower to the LLMs. Otherwise, Google Translate was a joke before that. Literally, I've used it, so I know it. It was absolutely a joke. It couldn't catch the context at all. Now it can end up teaching you some context. You know, a very nice application of LLMs could be you take a culturally very specific idiomatic phrase and you feed it to an LLM and ask it to give it in the context of Japan or some Scandinavian nation. It will try to do the closest match, culturally specific idiom. So, can you suggest some examples in the comment thread? All of us can learn from each other, can't we? So, recommendation engines are a miracle of modern technology. They are an absolute miracle which you and me do not even bother to think about. we assume that whatever Netflix is recommending or Amazon is recommending or XYZ is recommending, it's fine. Their job is to recommend. No, 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 no. Their job is not to recommend. Their job is to study your behavior and behavior of the closest matching demographic and then see what others were consuming that you missed out on and throw that in front of you. That is collaborative filtering. There are many tactics and techniques in recommendation engines, but the idea is to make you buy more. So if Netflix recommends certain movies, there will be two triggers for it. Commonsensical. One, your earlier behavior. If you have been fond of action movies, comedy, action movies, serious, action movies, horror. So Netflix knows that it's a good bet to show this guy more of action. But if your pattern is action movies, comedy, romantic comedy, rom-com, stand-up comedy, horror, extreme horror, political satire, the engine wouldn't really understand what is this guy up to. So you have a very Catholic taste in things. So the next thing it might try to do is to find a secondary behavioral pattern with a matching demographic and try to find some common link where your propensity to click would be higher. And you can go multi-layer deep into this. And over the years, these companies driven by sales, billions and billions of dollars of sales now are driven by this. So on Amazon, people actually end up clicking the recommended links and buying it. In fact, this is the kind of life and death power that these portals now hold on humanity. So there are many products and services that literally live and die by these recommendations. So if you're not getting recommended, maybe you will never ever be bought. It's not just that you will be sold on the online thing. You can also be there in the offline world. You can reach out, and a lot of your own SEO also matters. So SEO is search engine optimization. And nowadays we are talking of LLM engine optimization also, because people are moving away from pure search result reliance to LLM result reliance and so on. So are these examples clear? What was our topic? The invisible AI. Invisible AI, I mean, this is for those who say, let's ban AI. You'll have to stop watching Netflix at all. I mean, completely. And you'll have to stop using Amazon because all the recommendations are AI. In fact, any social media, it's all recommendation. Even the recommendations on LinkedIn or Twitter or X to follow somebody, it's driven by some logic, right? It's driven by some logic, mathematical logic. This is another very, very powerful use of AI. And with every passing day, this is becoming more and more refined. Earlier, if you were using Google Maps and any transportation aggregator service like Uber or any other, then there was a starting point, there was a destination, and then you had the satellites in the sky guiding you through the triangulated mechanism, very, very complicated mechanism of GPS or any other system that you might use, and you reach the destination. There was no integration with the various landmarks and the traffics and the disruptions en route. As things progressed, the modern ETA, estimated time of arrival calculations, are actually based on every possible variable that the system can track in real time. So the ETA can keep changing. And this is helpful in many cases in a very dramatic way also. It can take in real time traffic, historical data, user movement, and then the entire dynamic pricing thing works on this. This can be exploitative also, especially in air travel dynamic pricing. I mean, it's price gouging mostly. But here we have a dynamic pricing thing for, say, cab hailing or taxi booking stuff. All this is possible because real time AI is analyzing at a pixelated level what is happening. Now, the interesting thing about AI is that with every fresh data it is ingesting, it is getting more and more refined. Remember, I told you that machine learning is all about pattern recognition. So more is the data, more is the pattern, more is the data, more is the pattern, and more would be the propensity to recognize better. So we are discussing why AI is invisible and you cannot get rid of it now. Digital assistants. Of course, all of us use them. Siri, Alexa, Google Assistant, irrespective of which company has created, they have a fundamental architecture which is the same. So suddenly they have started becoming very smart. For a long time, people used to mock these assistants that they have absolutely crammed up the responses, scripted response. But generative AI is turning them into actual intelligent agents. Intelligent, quote unquote, they are not actually intelligent. All of us who have, we who have been using these devices and these assistants for the past several decades, in fact, 20 years, 25 years, rudimentary initially, we realized that there's a very limited repertoire of responses they can actually generate. But then in the past 5 years, everyone is surprised to see how in real time they are actually able to modulate. And instead of hard coded rule, now there is a flexible agentic behavior. AI agents and agentic AI is an absolutely hot topic. Someday I will take up a whole lecture on it in case you're interested. In fact, you can list down various topics that you might want to learn one by one in the coming weeks and months. We'll take up things. Very, very happy to do that. So the future is Gen AI intelligent agents that can actually do complicated actions. Yes, there are deadly problems with this. Yes, there are real world risks we will encounter. But the forward march of technology has rarely been stopped in the past 800 years at least. So let's hope regulation keeps pace. Let's hope companies themselves create guardrails. We'll talk about prompt injections and other things in coming lectures. But for now, dynamic, conversational, context aware. So they know what to do for this particular user. This is AI in action. Email and search have been some of the biggest beneficiaries of machine learning. In fact, entire Google, the whole apparatus, the whole paraphernalia, Google is an original data company, the most original data company. The way the two founders created the page rank algorithm and then it evolved and evolved and evolved. And the way they now have more than 25 years of humanity's nearly entire data, except corporate databases, which are not on the internet, they have put it to good use. And two of the most successful AI applications are email spam filter and search ranking and understanding what they are going to rank. I remember around 10 years ago, people were amazed that in YouTube, the moment I type one alphabet, it suggests things and mostly they are right. This is the power of machine learning. This is how machine learning actually works. So you keep typing and you end up getting more suggestions because it doesn't have any magic eye. It has used millions and millions of patterns and it is proposing that. And if the topmost link gets selected, then it knows that, okay, it has done a good job. So there is a reward for it. If it doesn't, then it knows it was doing a bad job. So it will do some introspection. Sorry for using the anthropomorphic terms, but that's how it is. So what is AI doing? Very silently, it is optimizing your life's digital experience. It is filtering out noise. It is understanding context so it can recommend the right pizza. Ooh, we are on the last chapter, strategic outlook. I am amazed that you're still with me. That means I did a good job. That means you did a good job. That means Billion Hopes is going to do a good job. So why not subscribe right now and why not even join the channel? There are going to be amazing things in the paid membership as well. So let's start 26 to 30 and let's wrap up this beautiful masterclass. And then we will be ready for more videos all through the week, more shorts also. And then the next masterclass coming up, it's a series of 7, as I said. So now we are talking about the AI gold rush. So suddenly we find that these companies are showing trillions of dollars in valuation. So where are these sums coming from? These sums are the reflection of the market sentiment analysis going by the basic fact that the three magical elements have come together in an unexpected way. Big data, big compute, best in the class or SOTA algorithms. All three have fused together to create LLMs which divide to conquer. At a pixelated level, they have controlled the universe now, or they have analyzed the universe now. And the market thinks that this is an unbeatable combination. But LLMs are not the end of the road. LLMs will not get us to AGI or ASI. So we'll spend a couple of minutes understanding AGI, ASI, although the last lecture in this series will be totally dedicated to that. So now, those who are selling the shovels in the gold rush, those who sell shovels become the richest. That is the GPUs. They made the most money. Then these companies are actually the gold mines because they have the data. They are actually running the models. NVIDIA does not run an LLM that you and me use on a daily basis. And finally, the jewelry makers, all the productivity apps, creativity apps, communication apps, entertainment apps, there are many very powerful AI tools available today which rely on LLM. So the backend API call is to an LLM. Every time you feed something into, say, DeepL, which is a beautiful language app, AI tool. I'll keep discussing various AI tools also. If you are an AI tool maker or your company has an AI tool, share it with us. We may one day feature it. That in the backend runs on a certain model. It can even allow you to change the model. For example, Leonardo. Leonardo is a very good visual tool, video maker, image maker, and it allows you to choose a model with which you will do the manipulation of the starting image, etc. So, this is how the AI gold rush actually happened. Now, who will come out the final winner? I do not know. In fact, none in the industry know. And in fact, there is a talk of an AI bubble. So, let me just expound on that for a moment. So, is there an AI bubble? Absolutely, it seems to be. I mean, these are crazy valuations. But how do you know that? Well, the whole idea is that by 2030, individuals and corporates do not end up paying the kinds of money to use these AI tools and LLMs that justify the kind of investments they are making, the valuations they are commanding, then the whole party is kaput. That's it. That's the whole calculation. So if you see that the net cash flow and the kind of revenue retention that should be happening is not happening, then people will think that it's a bubble and everything will crash. Everything will crash? No, no, no. I meant that these companies' valuations will crash. Machine learning will not crash. It has nothing to do with valuation. Recommendation engines will still run. They'll run better every day. Netflix may crash. Recommendation engines won't crash. If you understand the difference between the two, you understand the game. The hype cycle. So this is various names are given, but this is a Gartner hype cycle. It may not be true in all cases, but for AI, people say that this is true. So Gartner hype cycle was created many, many, many years ago to explain that with any new technology, an innovation happens. So with LLMs, we had ImageNet by Fai Li, then we had the transformer architecture by Vaswani in Google, and we had OpenAI. Suddenly, everybody says, yeah, it's utopia. Come on, we are all going to have a universal basic income and free from all the work. And then suddenly we realize that the agent ended up doing wrong booking and I lost 90% of my money not getting refunded. Then slowly there's enlightenment and finally a plateau of productivity. We are not there yet. We are not there on that plateau of productivity yet because corporate adoption of AI is slow. So there's this beautiful book that talks about why you may invent the best technology in the world, but human society takes many decades to fully absorb it. Best example, electricity, electric vehicles. People took decades to adopt it at scale. Same with AI and machine learning. If not decades, many, 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 many years. Experts and the sensible folk know this very clearly, that no technological revolution. That is why, I always used to laugh. Now I just heave a sigh. When I read on social media, X company or rather ABC company just killed XYZ company. Nobody kills anybody. This model just launched. This is dead. Nobody is dead. No new product kills any other product overnight. There is inertia, momentum, the flywheel effect, the network effect. People don't switch overnight, no matter what you do, even if you pay them. They don't. That's human nature and it's good. There is check and balance in the system. Otherwise, human society will run like maniacs. So, these hype masters in social media, they are so irritating. This model just launched. It's all over. Nothing is over except your IQ seems to be over. Go ahead, subscribe, go ahead, like and share, and go ahead, become a member. Very, very happy for your support. Thank you so much, ladies and gentlemen. Let's wrap up the session. Weak AI versus strong AI. So, what is weak AI? Now, I'll explain this in the simplest possible language. So, there is a computer that can play chess. There is an AI system that can play chess and beat the best of the chess grandmasters. Can it drive my car, take me to the market, go and buy the right kind of bread loaf I want, come back home and prepare dinner, and then serve fresh brewed coffee without spilling it, and then clean up the bed and then lock the door and then allow me to sleep peacefully? There's no such AI. These are all stupid machines. There is no generalized intelligence. True intelligence, you and me, we are generally intelligent. We can do 100 different things in a single hour. No machine in the world can. And if some machine is being claimed to be doing that, trust me, today there's a massive human contraption being put in place from the backside, hidden from you. The company is lying. There's no machine like that today. The best of the robots are not general today. I don't know what happens 10 years from now. So you and me are miracles of nature. We are generally intelligent. Machines are very narrowly intelligent. They are weak. We are strong. This is called the Moravec's paradox. The easy things are hard and the hard things are easy. Making a cup of coffee and not spilling it and serving 10 people is a very hard thing to do for a machine. Solving a complicated calculus problem is a very easy thing for machine to do because there are clear rules. For humans, it is tough because our cognitive abilities developed over the past 10, 15, 20, 25,000 years, and modern language, modern math in the past 500,000, 2,000, 3,000 years. Everything else came genetically encoded in us in various parts of the brain over millennia, or rather millions of years. The hard things are easy, and the easy things are hard. It's a beautiful topic. It's a whole topic of research, my dear friends. So that's weak versus strong. This is why you need HITL, human in the loop. That's why you just don't have full autonomy in driving, because absolutely unexpected situations can arise which only a human can handle. And that is why every modern cutting edge AI system necessarily needs to have a human in the loop, either visibly or invisibly behind the screen. Keep that concept in mind. Human in the loop. Irrespective of the kind of systems you use, the autopilots used in the best of the aeroplanes today, and that's the best example. That's the best example of human in the loop. I believe we have completed this beautiful lecture, and now we are about to summarize everything. Did you enjoy the lecture or not? So be with me till the last point. Make sure you give me all the info I need to prepare the series of lectures ahead for the rest of the week and the next lecture in this beautiful series of 7. So, my dear friends, we just completed our entire syllabus. What a beautiful syllabus it was. I had 6 sections with me, or rather chapters, if you would. No problem. You can call them chapters. No issues at all. And in these 6 chapters, we actually saw wonderful things. In fact, 30 components. So now you can proudly tell people you know these 30 things at the basic level. What were you even afraid of? This is how we are going to deconstruct, demystify, simplify AI. It takes time. It's not easy, but we have all the time, right? We are going to do it. We are going to do it. We are going to do it. We are the 90%. We are not technical experts. We are not either the hype masters or the doomsayers. We are the 90% sensible human beings. That 90% which wants to learn AI seriously without any hype or nonsense. Yes, sir. And we are the billion hopes. Go ahead, watch all the videos. We'll soon have a huge collection. Go ahead and read Insights, insights.billionhopes.ai, a wonderful website. My team maintains hundreds of AI current affairs. The blogs on Billion Hopes site. Make sure you subscribe to the free AI for Everyone newsletter. You'll receive it regularly. Subscription link given. WhatsApp channel, make sure you join so that you get beautiful updates. The link for that is given in the comments. Take membership of this channel. There are absolutely exclusive sessions being conducted there, and check out all the courses on Academy and enroll as per your need or suggest, recommend to your friends. So, this was our first lecture. With that, we have set the tone, and I very sincerely feel that we need to have more and more of AI education for every human being on this planet, because if this is the technology which now we cannot get rid of, then we should try to be in charge. We should try to be in control. And how can you ever be in charge? You can be in charge when you're informed. You can be in charge when you are absolutely certain that you want to be in command. Right information, a right insight into how this magic happened, what was the mathematics behind it, is what makes things demystified. And once you remove that veil of magic on things, you start talking sense. So that's about it. This was your mentor, Sandy. This is your mentor, Sandy, bringing you AI for real impact. See you soon. Love you all. All your support is appreciated.